catalog. Here comes centralizing the access control using Unity catalog. It's a fine-grained governance solution for data and AI on Databricks platform. It helps us to simplify the security and governance of our data. And AI assets, which are mainly for data science and machine learning activities, by providing central place to administer and audit access to the required assets. Next, this Unity catalog supports RDD, the resilient distributed data sets, which are actually mentioned in the architecture notes also. We got it few classes back. Why it is supporting? Very simple. RDD is mainly meant for automatic error detection, automatic error correction by implementing a technology called checksum, just like any other database technology. And Unity catalog also talks about storage only. So Unity catalog is actually a storage media. Remember, it's a storage media. RDD is a technology to protect the storage. How it protects? By giving us the options for automatic error detection, automatic error correction. I repeat again, Unity catalog is a storage area in DBFS, backed by Hive and Hadoop storage racks, physical storage racks. This Unity catalog supports RDD technology set of programs written in Spark that will auto detect and correct the errors in the storage level, if any. Then comes Delta Lake. It's an open source software. It is an open source software that extends Spark data files to support data capture. Using Delta software, we can implement something called incremental loads. Okay, and using Apache Spark. So to implement this Delta Lake, we use Apache Spark. So for this, during table creation in our earlier classes, we mentioned Delta option. Create table name, like if you remember, hope you practiced earlier classes, like orders table, inventory table. Those two tables we learned using Delta, and then we perform merge into statement. Remember what is it? Merge into. Please be informed. Let's be very clear in what we learn. Merge statement is different, merge into is different. Really, merge statement is different, merge into is different. Merge statement is for MS SQL. Merge into is for Spark SQL. Spark does not support merge statement. MS SQL does not support merge into. Remember, purpose is same, but the statements are different. MS SQL we say merge target using source. Spark SQL we have to say merge into target using source. So if in case you're planning for certifications or online interviews or any kind of our day-to-day activities, if we hear or see merge into, means it is Spark SQL. Just merge. Then it can be MS SQL. And automatically, remember, whenever we create a table with Delta, this is important, automatically that table will have internal timestamp columns to trace the history or log of the DML operations. Whenever we say Delta, table cell internal timestamp columns automatically. This is what it used to happen in temporal tables. We have them in MS SQL, PostgreSQL, Snowflake, and few other specific database technologies. Remember, friends, we are not talking about temporary tables. We are talking about temporal tables. What is that again? Nothing new, simple. Whenever we create a table, okay, automatically, internally, some timestamp columns will be auto created. In olden days, we used to create timestamp columns manually and do the comparisons, comparing timestamp columns or watermark columns. With temporal table technology, we have timestamp columns automatically in the table, internal, and they are used for performing this change capture or delta activities easily. So this kind of checking for the new rows and performing DML operations on existing rows, we call it upset, updates for existing rows, inserts for new rows. During your free time, please see if you can get information on this beautiful item, temporal tables. If possible, in MS SQL, to get to know more how it actually works for upset activities, either regular Synapse SQL pool, or you go for Apache Spark pool, or maybe in future you are going for your Snowflake or Amazon RDS, sorry, Amazon Redshift, not RDS. RDS is OLTP, Redshift is warehouse. Anywhere, it will be easy for us. Any help on this, I am there. Try to get the information on temporal tables and do let me know. Next, there are three important tables actually, okay? Temporal tables, memory optimized tables, temporary tables. Temporary tables anyway temporary, like for housekeeping activity, session level in SQL and notebook level here. Other ones, temporal memory optimized tables. Try to get the information. I am there, use me. Next, we have something called delta live tables, also called DLT. What is this? Hearing for the first time. Very simple. Delta live tables or DLT is the best way to implement ETL process in a lakehouse with live real-time data sources. This is the place where we are going to integrate event hubs. What is that? I'll take an example. I'm just getting the ground for our next examples. Event hubs, they are known for live real-time data. Even in DP203 certification also, it was specifically mentioned about event hubs and DLT clubbed together. Hence our example. We need to value certification not from exam point of view, but from proprietary Microsoft implementation point of view. We need to value it. The other side of certification. Well, here it is. Event hubs are mainly for the purpose of tracking the events, okay, for live data ingestion. So those event hub data can be tracked by our PySpark notebooks, perform cleansing, filtering, aggregation, adding the required surrogate key, ETL date, and then load it to the warehouse. Which warehouse? Maybe Spark warehouse or Synapse warehouse. Okay, that is our actual concept. Next, DLTs are responsible, delta live tables are responsible for creating, maintaining, and testing data flow pipelines for easier management. Very simple and straight. Why? Very simple, very straightforward reason. The delta live tables will have their own timestamp attributes automatically. That's why it is very easy to do upsert activities. They are responsible for performing data transformations and managing the task orchestration, cluster management, monitoring, quality, and error handling activities. What does it mean? Very simple. Delta live tables are known for auto start of the cluster, and auto pause or auto termination of the cluster during their ETL activities, just like our job clusters we learned earlier classes. You remember? All purpose cluster, we need to manually pause it or set some time wherein there is no activity for specific amount of time, they get paused automatically, right? That is what we learned here in our regular workspace activity. Starting of our classes, when we started with our module, this Databricks module, we learned while configuring the cluster, we put some time, some particular 60 minutes, 30 minutes time for compute to get auto terminated. That is called all purpose cluster. Then we also learned in workflows concept. Workflows are nothing but jobs, Databricks jobs. We learned Databricks jobs with the parameters. There we have something called job cluster. Job cluster is automatically terminated once your Databricks job gets executed or job completion happens. Job completion occurs. Now, Delta live tables are more smart. Whenever we do DML or upset, whenever we do upset, cluster starts. Whenever the upset completes, cluster stops immediately. That's actual concept here. So whenever we implement this delta live tables, a smart way of performing the incremental loads, remember extra cost is involved. Just with an extra cost, we can have that additional advantage. So here it is. We learned something called merge into, orders table, inventory table. That example we learned merge into. Whereas Delta Live table supports CDC, change data capture. It is